So this is a video for number 4 from the Waves and Sound homework. And this is the one where you have to look at the longitudinal waves and identify, where the amplitude, equilibrium, all sorts of stuff. The problem is actually right over here. But most people struggle with this animation and understanding how to make sense of it. So let's focus on that. So the first thing I'm going to do is I'm going to draw an arrow right where this piston is starting. And the reason I'm drawing this arrow is this is the equilibrium position for the piston. So that's the equilibrium position for the piston. And what I want to observe is how everything looks right there where the piston is when the piston gets back to equilibrium. And so let me just start this. So I'll hit start. And I'll stop it right there. And you can see everything's compressed. It looks like this is max compression. I stopped it just before equilibrium, but still we can see there's max compression. And then when it comes back, max rarefication. Okay. So max compression, max rarefication. So the points that are there at max compression or at max rarefication, those points are at equilibrium. So if I go back to my particular problem, and I'm looking here for, let's see, at the moment shown, which points are at equilibrium. Okay, so here's my diagram. And you can see now D, E, and F are all clumped together. And you might be tempted to pick all of them, but no, because we're only picking one, because only one of those is actually at equilibrium. And so, I think it's pretty straightforward reasoning. E is the one that's experienced the most compression here. So E is going to be for me at equilibrium, but it's not the only one. Also remember max rarefication when they're furthest apart. And so what you can see here is that's going to be for me points A and I. So those points are at equilibrium for me. Okay, so what about amplitude? Okay, well, amplitude is going to be between the two equilibrium points, right? It's going to be halfway between. So based on points going halfway between, that's going to be points G and C. So which points are at the amplitude? Okay, so that's points G and C. So these points are at the amplitude of their motion. Now let's go back and take a look at what happens to those points that are at the amplitude. So we can just look at, for starters, we can watch the piston here. And it gets to its amplitude. And of course, that's when it's going to stop moving and then change direction. Gets to its amplitude, same thing. It has stopped moving. And you can tell it's stopped moving because if I move it forward, see I'm clicking it forward and back, you'll notice the piston isn't moving. And the piston isn't the only point that's not moving. If you look at these two lines right here, as I go back and forth, really it looks like this one to me, but it's a tough call as to which one is, I guess actually it was this one, which one's not moving. But the point is, they're at the amplitude, they're not moving, as we already know it should happen. So I've identified the amplitude, I've identified equilibrium. So now this one, okay, which points are moving to the right, which points are moving to the left? Okay, so you want to get something, some kind of setup so it looks something like what you have here. Doesn't have to be the whole thing looks that way, just at least some part of it. Okay, so mine, I've got this clump in the middle. Let me hit start. Okay, so this is pretty close to what I've got. It's not quite perfect. I don't have a whole wave here. I don't have absolute max rarefication because this hasn't returned to equilibrium, but it's pretty close. And that's all I need to understand what's going on. So let's see, mine is, it says the waves are moving to the right. Okay, so since the waves are moving to the right, that means hitting this right arrow here is what I want to do. That's going to move the wave to the right, and I can see what's happening. And what I'm looking for right now is I want to find these amplitude points, these points that aren't moving. And I think I found one. You take your eye off it, you lose it. So I might have lost it, but I'm going to, let's see, let's go with green here. I think it was this one here. And if I'm wrong, I'll just have to redraw my arrow, but I think that's the one. So let me try this again. So we go forward. Yeah, that one's not moving. So that's an amplitude. Okay, so I've identified that amplitude. Now I want to identify the other amplitude. So I got to look somewhere over here. And sometimes it looks like there might be two that aren't moving. That's just the way this, two side by side that appear not to move. And that's just a limitation of the animation here. But I think I've got the one that isn't moving for me. Looks like it's for this one here. And so if I draw my arrow again, I believe I said it was this one. Okay, so those 2 points are at equilibrium. So as I move forward, those 2 points don't move. And so the question is, as I go to the right, so I'm going to hit this button, so the wave's moving to the right, all these points in between those two, what are they doing? What are those points doing? And so if I hit it, I just look. Oh, okay, I can see what they're doing. And hopefully you can see as well. They're moving to the right. Okay? So here I'm going to hit it again. Those points, all those points are moving to the right. And what about these points over here to the right of this equilibrium point? Okay, what are they doing? Okay, they appear to be moving to the left. So let me do that again. And same if I look over on the left side here, same idea. They're moving to the left. Okay. So that's the idea. That's how you're supposed to go through and analyze this. This longitudinal stuff, it's difficult. It's difficult to visualize. It's a little difficult to make sense of. We don't see it very often. You probably have never really truly analyzed a longitudinal wave. Takes a little practice, but it helps to identify, hey, like equilibrium on the piston, so you can see what's happening at the equilibrium position, and then to find the points that are the amplitude, the points that aren't moving, and just move, kind of frame by frame to see what's happening, so you can come back here and identify the correct answers, for your particular diagram. All right, that's all I have to say about that.